Similarity, right? When we've got things that are similar, it means that they are of almost identical. However, they've been scaled up or down. So as we can see, these frogs here are all the exact same copy and pasted picture of a frog, but they're different sizes and they've also been rotated, right? So we can sometimes get confused with those rotations as well. It would be the same for if it's been flipped. Um, it can still be the same shape. It just is rotated or flipped a different way. But the difference between similarity and congruency is that congruency shapes are identical. These can still be flipped or rotated, which this isn't the best example. This frog could be facing this frog like they were gonna, I don't know, sing a duet, but they don't have to be. They could be facing the same way, but they are identical pictures of the same scale. They are 100% identical. When it comes to shapes, the way we decide these things is because if we've got measurements, either angles or lengths, that is how we determine whether two shapes are similar or congruent. Okay, so let's go here. So polygon shapes straight sides are similar if the corresponding angles are equal, corresponding sides are proportional. So just to be clear on what that means, for these two shapes here, these are a rectangle, and each of the interior angles is going to be 90 degrees. This one matches with this one, that matches with that. They're both 90, both 90, both 90, and that would mean that we are in the right place. However, we do have measurements that also need to line up. When we talk about deciding whether these things are the same or not, there's going to be a formula kind of that we're going to use. We need to decide the ratio between the two pictures. Okay, now a ratio side lengths of 6 to 3 or 4 to 2. We can kind of go through and assess these. So 6 to 3, if I'm looking from 6 to 3, just notice I'm going from the big shape to the little shape. That ratio, 6 divided by 3, is equal to 2. If I do the same order, so I go from this shape to this shape for these also sides, 4 to 2, 4 divided by 2 is equal to 2. We've proven that these two side lengths are going to have the same ratio, right? That's the ratio is 2. We could also talk about it as scale factor, but just in our heads, we want to get used to the idea of, right, if I'm multiplying a number, right, if I multiply 2 times 3, what does it become? 6, right? If I multiply 6 by 2, what do I get? All right, see how it gets bigger, right? If we wanted to go backwards, if we want to work from the bigger shape to the little shape, we do the opposite. 6 divided by 2 is 3, 4 divided by 2 is 2, right? So the scale factor is still there, or the ratio is still there, but we need to be really cautious of which way we're working. Congruency, identify conditions for similar triangles. For triangles, there's several different things we can refer to confirm that they are the same, right? Now, there's congruency tests, all right? These are what these are. Angle, angle, angle. If all three angles are the same length, we can confirm that they are congruent. We can confirm that they are similar. We can't confirm that they are congruent. Because if I could expand each of these out and the angles would stay the same, right, as they are here. This is 40 degrees, this is 40 degrees, this is 80, this is 60. They are proven to be similar, but not proven to be congruent. If we go here, so side, 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 4 by 4 by 7, this means if the other one was 4 by 4 by 7, we could confirm that it's congruent. However, we need to confirm that this is similar, so they need to have the same ratio. Now, once again, we need to really be really careful, right? So if I'm just going to line up, these are facing the right way. That 4 centimeters lines up with that 12. That 4 centimeters lines up with that 12. And that 7 lines up with that 21, right? So I could go through and do this. Now, it is easier working from bigger to smaller. If I go 21 divided by 7, it gives me an answer of 3. If I go 12 divided by 4, it gives me an answer of 3. If I go 12 divided by 4, it gives me an answer of 3. If any of these are different, they are not similar. They do not be similar. The side, side, side means they all have to have the same ratio. This last one, the side angle side, 2 pairs of sides in the same ratio and an equal included angle. So if I've got this side and this side and this side and this side, the angle I need is this top one, right? If I have this angle, it might actually change based off these two lengths. Side angle side, so we want the angle to be in the middle if you're not sure. And we would need to double check the two side ratios. So 6 divided by 3 is 2, 10 divided by 5 is 2. We can tick off that those are in the same ratio. And if the angle is equal, we're right to move on again. Alrighty. Determine whether the following pairs of triangles are similar or not. So we need to use our side or our angle or our side. This one here, what do we have? We got two angles. Does anyone know what the third or how we could find the third angle for a triangle? Perfect memory, thanks. So all angles included in a triangle need to add up to 180 degrees. Okay, so if this is 126 and this is 32, we need the third side, it would be 180, take 126, take 32, right? For that, if we call that one A, for this one, we'll call this one B. We're going to have 180, take 126, take 22. Now, based off that information already, can we prove that these are not the same? That these are not congruent? Oh, these are not similar, sorry. Maybe. We got to think about translating the shape. So if we rotate the shape around, right, if we turn it 180 degrees and slid along, this side here would be the same as this side here. So we need to check if this equals 22 and this, if this equals 32. This one here, sorry, equals 32. So let's solve them. I don't know if you guys have got calculators out. We'll just do it. In the situation where we're just using this, we're going to make it nice and easy. So 180, take 126, take 32, equals 22. So this one here would be 22 degrees. Then we would have 180, take 126, take 22, equals 32. All right, we can prove with angle. So the angle test proves these are similar. Right. This one, what are we using for this one? Angle, side, angle, side. Side. So the first thing we do is we need to pair up these sides, right? This side matches with this side. This side matches with this side. This side matches with this side. Now, big and a little, remembering that makes it easier. 78 over 32. Then we're going to do 105 over 45. Then we're going to do 48, 26, right? So we're going to check each of these. So 78 divided by 32. 78 divided by 32. Give me an approximate 2.4375. We go 105 divided by 45. Gives me 2.3. Continuously 48 divided by 26. 1.84615. Are these going to be similar triangles? No, because these are different. These are not similar. Different ratios means these are not similar. Or congruent. All right, so scale factor. Moving on, because I'm going to do, maybe I'll give you guys a quick